Hi there, John Clinch here, physics teacher at Luton Sixth Form College. Just here to give you a quick sample bit of physics teaching. I'm going to just spend a few minutes looking at units, get an idea of the sort of things that you might be doing in a lesson. The intensity of the sun has a maximum value of 1000 watts per metre squared. A solar panel has an area of 4 metres squared. The solar panel is connected to a battery capacity 6000 watt hours. How long will it take to charge the battery? And you're going, well, you haven't taught us any of this stuff. I've not heard of intensity, you've probably heard of area, may or may not have heard of battery capacity. But what we have got in each case is a unit, haven't we? So we've got watts, power is measured in watts, meters squared, that's a measure of area, but because it's m to the minus 2, if you remember x to the minus 1 is 1 over x, so m to the minus 2 is 1 over meters squared. It's saying over meters squared. So whatever intensity is, it's equal to power, which is measured in watts, over area divided by meters squared. I think the area of 4 meters squared, you're fine with that. The battery has a capacity of 6000 watt hours, not per hour, but watt hours. So the capacity of a battery must be equal to the power measured in watts, and what's measured in hours? Time measured in hours. So going back through, we can get time from the capacity and the power, but we need power. But if we look here, we can rearrange here. Power is equal to intensity times area. So let's try that. So the power is the intensity, which is 1000, times the area is 4, gives us 4000 watts. Then the time is equal to the capacity divided by the power, which is 6000 over 4000, which is 1.5 hours, or 1 hour 30 minutes, all just by looking at the units. So most of what you've been doing in physics lessons is this kind of mathematical reasoning. It's not all about the units, of course, and loads of other things. But then we often get this second part, which I really wanted to emphasise. I won't write it all out, but why in reality would it take longer than this to charge the battery? Well, to start with, we said the intensity then has a maximum value of 1000 watts per metre squared. So we only reach that maximum value if you're actually right in the tropics with the sun directly overhead. So part of the answer is because the sun is unlikely to have an intensity on the Earth's surface of 1000 watts per metre squared, because the light is an angle. Up here in the northern hemisphere, the light's spread out over a bigger area. We get an intensity of less than 1000 watts per metre squared on most of our solar panels. The atmosphere and clouds can block some of the light, so that reduces the power. And there's bound to be some losses in the wires. So in summary, intensity will be less than 1000 watts per metre squared, either because of where we are on the Earth or because of losses in the atmosphere or clouds. And there must be other inefficiencies, such as energy lost when we're transferring the energy from the panel to the battery. Okay, so I'm going to give you some multiple choice questions for you to do based on that.